Hi everybody, we're here and we're going to go over section 1.3. We are going to solve x squared plus bx plus c, which we know as a quadratic in standard form, but we're going to do it by factoring, okay? So the first thing we need to know is, what's a monomial? A monomial is an expression, either a variable or a product of a number and a variable, okay? It's an expression where there's one term, meaning that mono means one, and it can be a variable or a number multiplied by a variable. So for example, it could be x. It could be 2x squared. It could be whatever. It can be anything multiplied, but you can't add anything to it. So it needs to be one term, okay? A binomial, you probably can tell, is an expression with two terms that has basically two monomials and they're being added or subtracted. So for example, if we took the monomials x and 2x squared and we added them, that's a binomial. You could also do something like x plus 1 is also a binomial because we have two monomials added or subtracted together. And then the last thing is a trinomial, and as you can probably tell, it's three terms being added or subtracted together, okay? Basically three monomials. So for example, we could have had 2x squared plus x plus 1 is a trinomial. There's three parts. You could have had s squared minus 3s plus 2. That's also a trinomial. You could have had 4x to the 5th plus x to the 4th plus x squared. Those are all trinomials, okay? Let's go ahead and do example number 1. We're going to factor the trinomials of the form x squared plus bx plus c, right? And it looks kind of like standard form, but remember that x, there's just a 1 here. And on our graphic organizer, we always look number 1. We always look for a GCF, right? And number 2, we count the terms. So how many terms do we have? So we have 1, 2, 3 here. So we look for 3 terms, and the a value on the x is 1. So we use what's called x factoring. And we're going to put the last term, which is 20, we put that on top. And we put the middle term, or the b term, on the bottom. We have to figure out the factors that will multiply to 20 and add to -9. So what you can do is you can either list your factors visually or you can do it in your head. So I know I'm just going to always start with when I know my list is 1 and 20, and then I'll go 1 more, 2 and 10. 3 does not work. 4 and 5 work. And then you start kind of going backwards there. So which of these numbers could make, either by addition or subtraction, a 9? And I see it right here. So I know 4 and 5 can make a 9, but remember, this is a -9. So for that to work, they both have to be negative, okay? So then let's double check it. Does -4 times -5 equal +20? Yes. -4 and -5 add to a -9? The answer is yes. Okay, so we're good. So now we're going to take these numbers and we're going to put them inside our parentheses. Now we know in order to get x squared, we've got x times x. That's where that comes from. But now we're going to insert this one here, so -4, and this one here. And we've got our factors. All right, let's do the next one. So again, we've got 3 terms. There's no GCF. There's a 1 in front here, so we know we can use the x factor. We're going to put the last term on top, that's C term, and the middle term on the bottom. We're looking for the factors that multiply to -12 and add to 3. So let's list off our factors of 12. Okay, and then we kind of start going backwards. So let's see which of these could make a 3. So we're looking at them and I'm thinking, uh-oh, I don't see that there's actually any factors. So if there are no factors, we can't factor it. Okay. So here's a new thing for us. Now we have a special pattern. We did talk about this in our graphic organizer, but if we're factoring something that is 2 terms that are perfect squares with a minus in between, that's called a difference of 2 squares. And the pattern of that is that you'll have 2 parentheses. One's a plus, one's a minus. You take the square root of the first thing and put it here and here. Take the square root of the second thing, put it here and here. Okay? So for example, they had x squared minus 4. We saw that there were 2 terms, both squared, and there was a minus in between. So we set up our parentheses. One's a plus, one's a minus. The square root of x squared is x, so we put them first. And the square root of 4 is 2. Okay. And then we have this special one that's called a perfect square trinomial. Basically, you would recognize this as 3 terms. And it may or may not have the a value as a 1 or more. Basically, you would have to recognize this, that this first term is a perfect square and this first term is a perfect square. And that when you add the 2 terms together, or excuse me, multiply those 2 terms together, the middle term is double. Okay? And the way that goes is if these are perfect squares and they're all if this is being added here, it would go parentheses squared a plus b. Okay, now this is a special circumstance and this is not always going to jump off the page at you. Okay, so our way from our graphic organizer of factoring a trinomial with anything, it will still uncover this perfect square trinomial. Okay, so let's just say, for example, we had this x squared plus 6x plus 9. I do notice x squared and 9 are perfect squares, right? The root of x squared is x, the root of 9 is 3. Now, what if I added them together and doubled it? So x plus 3 would be 3x and double it would give me 6x. So this happens to be one of those forms. So I know I can put my parentheses and we're going to go the square root of the first one, add the square root of the last term, and then we square both sides because it would be squared. So let's go ahead and factor these with some special patterns. So again, on our graphic organizer, remember Our graphic organizer said we always look for a GCF first. And then we looked at the number of terms. There were 2 terms here, so we're looking for a difference of 2 squares. So let's check it. Is there a difference in the middle? Yep. Are the first and the last term perfect squares? Absolutely. So if we have, for example, something in the form of x squared minus a squared, this would become x plus a and x minus a. So here we go. We're going to set this up. One's a plus, one's a minus. The square root of x squared is x. The square root of 49 is 7. Okay, and then for this next one, the next part of our graphic organizer, both of these were 3 terms. This had an a value on the x squared of 1, and this one was bigger than 1. If we have 3 terms, remember we did our x factoring, and if we have 3 terms and a is greater than 1, we do what's called x grouping. Okay, so let's see what we have here. I see right in front this invisible 1, so we're going to be using this one on your graphic organizer. And we're going to use our x group, or excuse me, x, x factoring. We're going to put this on top, middle term coefficient here. We're going to figure out what factors of 36 multiply to 36 and add to positive 12. So again, we're going to list off our factors. 1 and 36, 2 and 18, 3 and 12, 6 and 6. Oh, I missed one. We also have 4 and 9. Okay, so which of these factors will give us a sum of 12? I can see it right here. Okay, I'm going to leave some space for me. Here we go. So now I'm going to set up my factoring for the trinomial. We're going to go parentheses, parentheses. Take that first term, square root it, and put it here and here, because we know those first terms have to equal this because of foiling. Now, we know that these are 6 and 6. They're both positive, so we go positive 6, positive 6. But look, that was a perfect square trinomial. So this becomes d plus 6 squared because there were 2 exact same factors. Okay, last one that we're going to look at. Again, our a term is 1, so we're still going to use the x factoring. So we put our last term here. We put the middle term here. Oops. And then we're looking for factors. So we know there's 1 in 169. 2 doesn't work. 3 actually doesn't work. 4, I don't know. All I know is that these would be 13 and 13, which goes along with our special case of a perfect square trinomial because this is perfectly squared. So we go 13 and 13 here. But remember, this is a negative on the 26. So both of these terms should be negative. And let's check it. If I multiply negative 13 and 13, we get positive 169, so we're good. And if I add them, we get negative 26. Okay, so we're ready to move on. Set up your parentheses. We know z and z go here because z times z is z squared. And then we put these terms here and here. They're both the same. So we write this as z minus 13 squared. Okay, and here's something that we need to make sure that's in your notebook. This is called the zero product property, okay? So essentially, what we're looking at is if 2 values multiply together and equal 0, either one or both of them have to be 0, right? Because the only way to get a product of 0 is if one or both are 0, okay? So for example, if you had this right here, if you had some factor x plus 5 times x plus 2 equals 0, we know that either x plus 5 is 0 or x plus 2 is 0. And if that's the case, then we could say x plus 5 equals 0 or x plus 2 equals 0. And then you can solve them for x. We would subtract this one by 5. We would subtract this one by 2. So in order for those two factors to multiply to 0, x has to be negative 5 and or x has to be negative 2. So let's practice this, okay? Also, really quick before we do this, there's these synonymous words. I don't know if I spelled that correctly. I'm not a spelling teacher. There are these synonymous words. They are roots, are the same as zeros, are the same as x-intercepts. Okay, so if you ever see any of those words, roots, zeros, x-intercepts, they're all interchangeable. And basically that means exactly what an x-intercept is that it crosses the x-axis at that point. Okay. It's on the x-axis. Okay. So when they say what are the roots, we're basically saying what are the roots, or what are the zeros, or what are the x-intercepts. So let's do this. So first thing we're going to do is we realize, okay, I'm going to have to factor this. You're going to use your graphic organizer. There's 1, 2, 3 terms. There's a 1 in front here. So you're going to use our x factoring. Put the last term here, 36. Put the b term here. So what multiplies to 36 that adds to negative 5? So let's list our factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and that's it. So let's see which of these could make a 5. Either adding or subtracting. Okay, so I see that 4 and 9 can make a 5 by subtraction. And because our 5 here is negative, we know one of our factors has to be negative, and it has to be the bigger one. Okay, so whatever sign this bottom factor is, make your bigger factor that same sign. And let's check it. 4 times negative 9 is negative 36. That's good. How about 4 times negative 9, or 4 plus negative 9 is negative 5, and that works out as well. So now we're going to set up our factor, okay? I'm just going to make some room for myself. So we're going to factor it right here. We know this factors 2, x plus 4, x minus 9. Bring down the equals and the 0. And now this right here is when we use our 0 product property. And we know something times something that equals 0, one or both of them have to equal 0. So we're going to say, okay, set x plus 4 equals to 0 and x minus 9 also equals to 0 because one of them or both of them have to be 0. And then we're going to solve. Subtract the 4. You get x equals negative 4. Add the 9. And x equals 9. So those are our roots. Those are also the zeros or the x-intercepts. Okay, that's it for part